Okay, 6 years, this is just a few of the more difficult questions from your classwork this week, a solution to them, right? So if there's any more you want me to go through, we can do it during class next week. I'm going to start with page 396, question 7, okay? Page 396, question 7. No, I did question 7, so question 8, sorry. So, if tan c is equal to 1 over root 3, find sine c and cos c. So this is where we just create a triangle. Don't forget we're still on right angle triangles now if we're using the tan. I'm going to call that c. Tan is opposite over adjacent, so 1 is opposite, root 3 is adjacent, right? So I need to find x. X is hypotenuse. So x equal to the square root of 1 squared plus square root of 3 all squared. Square root of 3 all squared is 3. 1 squared is 1, so that's the square root of 4, which is 2, okay? So now I can put that in there. So straight away I can get sine c is equal to opposite over hypotenuse 1/2, 1 over 2. Cos c is equal to adjacent over hypotenuse, which is root 3 over 2. I'll leave my answer like that. Question 9. So tan a is 3/4 this time, so call that a. 3, 4, 3 squared, 4 squared is 25, so this is going to be 5, okay, using Pythagoras. This time it says find the value of sine squared a plus cos squared a, right? So let's find sine a first. This is where the question is a bit different, but just go with what we know how to do and put it into the question. Don't get thrown by the different wording. Sine a is opposite of hypotenuse, 3/5. Cos of a is equal to adjacent of hypotenuse, 4/5. So sine squared a is 3/5 squared, okay? Sine squared a is 3/5 squared. That's how they notate the squared for the trigonometric ratios. So remember, so that's 3/5 times 3/5, which is 9 over 25. Multiply top, multiply bottom. Similarly, for cos squared, a is equal to 4/5 times 4/5, which is 16 over 25. 4 times 4, 5 times 5. So sine squared a plus cos squared a is equal to 9 over 25 plus 16 over 25, which is 25 over 25, which is 1. And that's an interesting fact. Whatever the ratio, this is always going to be equal to 1. We'll get to that later in the topic. Okay, sine squared a and cos plus cos squared a is always going to be equal to 1. Okay, I'm going to move on to not the next exercise, because that should have been okay for you. I was trying to pick the questions that are very, I suppose, difficult. So I'm going to go on to the problem solving ones. I'm going to look at question 12 here, right? And a few from this exercise, page 401. Okay, I'm going to sketch the triangle, which I recommend you do anyway. Just good practice, I suppose. C, D, A, B, 35. And we are asked to find the length. Don't forget this notation is for length, CD, and the angle, CBD. Okay, So just notation, CBD means CBD, so this angle here, okay? So when you have problems like this with more than one triangle, you've got three triangles here, haven't we? 1, 2, 3. It says in the question this is perpendicular, which means it's a right angle triangle, which means we can use SOHCAHTOA. If that's a right angle, this is also a right angle. So for that, for CD, I've got this scenario here, 35, 6, and X. So again, just a tip, separate the triangle we're working on there into like a textbook question. That's opposite, that's adjacent, so O and A linked to tan. So we write tan 35 is equal to opposite, which we call X, over 6. Multiply 6 to both sides. 6 times tan 35 is equal to X. Okay? Let's do that. Make sure you calculate on degrees. Remember I said to you 6 times tan 35 equals 4.2. Check what it says in the question. 1 decimal place. So 4.2. Let's put that into our main drawing as well. 4.2. So if we can fill in the blanks, we might as well do it. So now we're looking for this angle. So I'm going to sketch this triangle. I know it's a bit of a pain sketching triangles separately, but it just avoids making mistakes, right? 4.2 and 9. Again, I want this angle, so let's call that B. Opposite and adjacent, so I can say tan B is equal to opposite, 4.2, all over 9. So if we want the angle, B is going to be equal to inverse tan. We'd write that like this in our workings, with a -1 there, 9. We type that to the calculator. It says in the question it's the nearest degree, so bear that in mind. Second function, tan. I always like to use the AB button because you know, I just do. Okay, 25.01, so it's the nearest degree, 25 degrees. Okay. Next one is one for the tree. Okay, so here again, I would just draw the triangle separately. Okay, we want the height of the tree. I'm not going to do this one for you, right? So that's the triangle. Draw the triangle. We've got the adjacent. We want the opposite. So tan 47. Tan 47 equals X over 20. Multiply 20 both sides. Next page, we have this one. A bit more problem solving involved in these. Okay, so you have to think about these, right, and what clues are in the question. The diagram shows cross-section of the roof with sides 7.5, 32. So straight away, I'm looking, even before going any further, I know that's an isosceles triangle, okay? Because that's going to be important. Find the height of H. So, if it's an isosceles triangle, if I pretend to cut that in half, you know, that's going to be a right angle, isn't it? So if I draw that triangle out separately, I've got 32 H. Well, let's do that. So let's see if I can get both of them in. No, I can't. Right. So that's the triangle I'm going to draw to get H. I've got H here. I don't know what this length is, but I know this is 7.5. I know this is 32. So we've got 2 bits of information. We can always find the third with trigonometry. I got this angle, opposite, hypotenuse, sine. So sine 32 is equal to opposite, which is called H now, over 7.5. Okay, multiply 7.5 to both sides. 7.5 times sine 32 is equal to H. Let's do that. Does it give us, find the height, give your answers correct, in meters correct to 1 decimal place. So 3.97 gives me 4 meters, okay? So H is equal to 4 meters. Find the width W of the support roof. So this is W here, that's the isosceles triangle. Oh, what's happened there? That's the isosceles triangle. That's W. So if I work out this length here and double it, then we're done, aren't we? So for this triangle, I got 7.5. I got 4 here now. We can use 4 because it said in the question to round it to one decimal place. So I've got 2 options. You know, I could use just, you know, I've got 7.5 originally. Adjacent hypotenuse of cos 32 is equal to, you know, x over 7.5, etc. Or I could use Pythagoras' theorem. You should get the same answer for both of them, right? I'm going to use Pythagoras just to jazz it up a bit, just in case you're getting sick of sine, cos, tan, you know. So this is not the hypotenuse, so let's call that x. So we're going to subtract inside the square root, okay? Square root 7.5 squared minus 4 squared equals, to one decimal place that's 6.3. So twice of that is going to be 12.6 meters. Okay, you're also doing, I'll do one more, question 19, right? So this is one here. Okay, in the triangle AB, so it's 10, that's given to us. BD is 2, ABC is 53. Write down the angle BAC. Okay. I'm just going to pause there for a second. So we've got 2 triangles. It gets a bit confusing. We've got 2 triangles here, right? Just simplify them. If I was you, I'd separate the 2 triangles, right, separately on the drawing, just because I think it just clears the mind a little bit, avoids any confusion. So I'm going to draw them separately now. I'll draw the big one, the outside one. So B, C, A. I know that's 10 meters. I know that's 53. Okay, this is literally just an exam type tip. Forget about D for the second. And the other the one inside that one, just going to draw the 2 triangles. Just a tip, it just clears, declutters the information. D, yeah, we don't have any information about that triangle because we just know that's 2 meters from here to B. Okay, we'll leave that for now. So so the first part is write out the angle BAC. So BAC. Right, BAC. We don't need trigonometry for that. We just know the angle. This is 90. That's 53. Angles in a triangle add up to 180. Angles in a triangle equals 180. So we take away 180 minus 53 equals 37. Okay. Next, it asks us for BC. So this point here. So now we've got options here now. So let's use the information we had originally, right? So I want to find out x. So I've got let's use 53, because we could use 37 and have opposite and all that, but let's use the 53 adjacent. Let's use we want the adjacent, we've got the hypotenuse. So I can write cos 53 is equal to adjacent x over hypotenuse. So x is equal to 10 times cos 53. Multiply 10 to both sides. I just put the x on the left hand side because, you know, it looks a bit easier. So 10 times cos 53 equals. Does it ask for find BC in the triangle? Yeah, it doesn't say here, so I think it's good math practice to put 2 decimal places, so 6.02 meters. And then it says DC. So if you imagine the original triangle, you know, I'm going to overlay this one over that one now. If that's 6.02 and that's 2, this is going to be 4.02, isn't it? So DC is equal to 4.02. Okay.